Heavenly Father, we thank you for this day and all its blessings. Keep us ever mindful of our responsibility to serve our community. Bless us with wisdom and guide us in our decisions so that we may be better stewards. Give us clarity so that we can effectively tackle each part of today's agenda, reveal problem areas, and lead us to the best solutions. Keep Jason Starkey and his family in our prayers, and we ask for rain for our watershed. We ask this through Jesus Christ our Lord. Amen.
Great, we'll move on to the presentation by Garber LLC for design of facility rehabilitation and upgrade to the Isla Blanca wastewater treatment plant.
Good afternoon, Vice Chairman, directors. It's great to be here today. Thank you for having us. We appreciate the time given for this workshop. Thank you as well for the awesome Laguna Madre staff. We're looking forward to this today. Hopefully it's going to be a very engaging and interesting workshop. It's hybrid. We've got the first part via PowerPoint, the second half via virtual reality tour. So my name is Isaac Wakuja. I'm a South Texas team leader with Garver. Garver is your engineering consulting firm. We serve the district on a variety of projects. Some recent efforts we've done for you all include the recent success of negotiating with TCQ some permit amendments to remove constraints, limits on the discharge at the Andy Bowie plant. Those were going to come into play later this month and would have resulted in hundreds of thousands, if not potentially millions of dollars worth of capital improvements that we're able to successfully remove. And now we're set for another 5 years. One of our other recent efforts, we successfully procured seawater desalination feasibility study funding from the Bureau of Reclamation. We got notice of that a few weeks ago. Oh, and the one for the Andy Bowie, the notice came in a couple of days ago, I think on Monday, which is pretty neat. And lastly, this effort today, which we're here to discuss, the Isla Blanca project, which we recently concluded, and we're going to dive into this workshop to discuss the results and where we're at. The intent is to give you, in the time allotted, an overview of what we did, how we did it, and where we stand. So this is basically the agenda for the presentation. We're going to go over an overview of the project, which is exactly what I said. We're going to go briefly over the overarching effort, what we did and how we did it. Then we're going to dive into the facility reviews, the facilities within the plant and what we saw and what we are proposing as solutions. That's part of the summary of recommended improvements. And then we're going to dive into the fun stuff, which is the virtual reality tour. And then we hopefully have some time for questions and answers. Now, we're saying Q&A at the end, but please stop us at any time. Glad to go off on tangents and discuss questions. We find that the best way to discuss those questions are when we're on the subject and when the question arises. So please feel free to stop us anytime, and we'd be glad to elaborate. So let me dive into introducing our team of experts here. I've mentioned myself, Isaac Wakuja, a project manager and team leader. And then I'll give a quick minute to the rest of the team to introduce themselves.
I'm Shane Smith. I'm the civil team lead on the project, and I'm also the color station water design.
Tyler Pietsky, I'm the process mechanical team leader of our color station. Lastly, I'm Brian Jonathan.
Thanks for coming down, gentlemen. You get over the island for dinner or something before you go home.
I do want to note, though, that although this is the team of experts that's here to serve you today, this is by no means the only team members that served you on this project. We're basically the tip of the spear, and there's a lot of great team members ranging from our expert team of technical writers to designers, technicians, and other professional engineers that work with us in this project. And at the end of the day, that's what we see that it takes to address some of these complex problems that Laguna Madre faces and to deliver these industry-leading engineering services that we know that you all deserve. So there's a lot of effort and a lot of team members that can join us here just for practical purposes, but we're part of this effort and serve the district in this project. So I'm going to dive into a project overview. The project itself is the Isla Blanca wastewater treatment plant. It's located south, the southernmost part of SPI. And The location itself is interesting because the simple fact that it's located on the island is uncommon. I mean, most plants are not. And then you have the fact that it serves what's arguably the most popular beach in the state, right? So by its location, you've got a couple of interesting constraints. One of them is that, again, being on the island, you're basically at sea level, right? So therefore, the impact of storm events is it's more susceptible to the impact of storm events versus if it was at an elevated location. And also, I guess, just in a nutshell, because of the location as well, more sand gets into the wastewater system than elsewhere, right? So you've got an elevated amount of sand getting into the system, which is one of the problems that we've seen and are going to be discussing. Additionally, the plant was built in 1983. It's rated for a 2.6 MGD, million gallons per day flow, and a peak rate of 2-hour peak rate of 7.8. So Laguna Madre Water District requested that multiple facilities within the plant be evaluated for potential repairs and upgrades. And let me take 1 second to go into terminology real quick. We're calling, so the Isla Blanca wastewater treatment plant itself is a facility, right? It's a facility within the larger Laguna Madre district. The district has several facilities, it's water and wastewater plants, etc. But we're only looking at the Isla Blanca wastewater plant today. So we're calling facilities across the presentation each sub-facility inside the plant, right? If we're speaking about the disinfection equipment, the disinfection system, that's a facility. If we're speaking about a clarifier, that's a facility. So we're calling facilities the components within the plant itself. So our task was to assess, evaluate, and basically address solutions or prepare solutions for some of the problems in the facilities described there, which we'll dive as part of this presentation into that.
I interrupt.
Of course.
Carlos, can we possibly move the podium to the side so I can see what the heck is going on?
Couldn't we slide our chairs this way?
Don't put it right in front of Mr. Donahue, but.
I'll slide this way, Adam.
Either way. There you go. You okay with that?
I'm fine.
That's fine. You okay with that?
You're perfect. No, it's great.
You can see that?
Yep, I can see.
Okay.
All good?
I was gonna do this and then I was like, oh,
I was curious why you looked at that screen instead of the one in front of you.
I like making eye contact, so I'm looking this way.
Might be good to turn off maybe the ones in the back.
Yeah, it's already.
Oh,
Of course, housekeeping items. No
Hope
problem.
we didn't throw your rhythm off.
What's that?
Hope we didn't throw off your
No.
rhythm.
All
right.
Where was I? No, just kidding. So we assess these facilities within the plant, and we'll dive into the details of each one as part of the presentation. So just for the purpose of giving you all this overarching explanation of the effort, we're breaking up the project into 3 tasks. The first task is basically that Garber perform an evaluation of the existing facilities. Our team mobilized, did a walkthrough through the plant, spent most of the day, a good chunk of the day at the plant, walking it, inspecting, assessing the facilities, discussing with the staff who's extremely knowledgeable. They're the ones that are at the forefront of the operations of the plant. They know what hurts, they know what the issues are. So discussing with them what the problems are, us also visualizing these problems, doing this assessment, taking photographs. We did a 3D scan of the entire plant. We went with facility evaluation forms, took notes, evaluated, etc. Did a full comprehensive evaluation of the plant. And then based off of that, we basically wrote the technical memorandum number 3. What you'll have in there is basically the culmination of all these efforts. Before this, we wrote 3 technical memorandums. And after each technical memo, we had a workshop with the staff to discuss the findings and discuss what we wanted to achieve on the next one. So this first one was basically each facility was given a condition assessment rating based on multiple factors, including equipment condition and the ability to meet treatment requirements. So after we compiled our findings into a tech memo, we visited with Laguna Madre staff. We went over our findings, and the culmination of that effort was that we were able to rank, and that's the list there in priority order. We were able to rank and prioritize the most important facilities that needed upgrades, repairs, or just needed to be done. As an example, number 1 does not exist. And they were basically ranked in with regards to the ROI, which one is going to have the most impact in operation, which is going to solve the most problems, what is causing the most issues. So that's how they were ranked. And so after that, after we got the ranking, we began task 2, which is when Garber used the initial assessment to evaluate solutions for the alternative, for the facilities. And we call this phase basically the alternatives evaluation. And what it means is we evaluated alternative solutions. So we're gonna be discussing as we move along alternatives, but that's the short form of saying alternative solutions, right? Because some of these facilities had more than one way to address their problem. And if you had a unlimited budget, there's even more, right? But we had to take into consideration several factors, including the planned footprint limitations. As we can see on the previous image, it's a limited space, right? You've got a fence line and there's no space to say, you know what, let's build a new facility over here. There's no space for that. So you have to take into account the planned footprint. You have to take into account the hydraulic limitations. We can't propose a solution that does not work with the current setup, the current hydraulics of the plant. And lastly, and probably most importantly, capital costs, right? We cannot propose something that's just not feasible with a realistic budget. So knowing that, we worked on alternative solutions for the problems we have identified on TM number 1, and the culmination of that effort is basically presenting those solutions and that TM number 2 with alternatives to the staff in a workshop setting, discussing the solutions, and basically deciding jointly on what the best solution for what the best alternative for some of these facilities were. And that's basically task number 3. After reviewing the alternatives from TM number 2, Laguna Madre staff, alongside with Garber, identified the preferred equipment types for each facility, and we did what we're calling the conceptual engineering, which is TM number 3. Now that the alternatives have been selected, we basically expanded on those selections. We did some layouts that we're going to be able to see, and we did more than that. We wanted to, and we were able to capitalize on our expertise in our team to deliver more value than we were originally maybe scoped to do so. In that we have this virtual reality tour that we're able to create. We're going to have these 3D renderings that you're going to be able to see how the facility would look once it's there. You're going to see, basically, a lot of that stuff, the impact is diminished because the facility already exists. But imagine if the facility didn't exist and you were able to visualize it in that manner. It's a substantial discussion tool to be able to walk through the plant and see how it looks and the layout. So that's a culmination of that effort. The last point that I want to make was that we, of course, have cost estimates for all of these facilities and these improvements. And the last slide just discusses a little bit on how that works. This graph here is an accuracy range graphic that just tells you how it works across the life of the estimate. As you move from concept from 0% to 30% to 60 to 100, your accuracy increases, right? So we're right now at what we would call, if we were doing the project from 0% to 100% design, which means that you begin construction, we would say that we're around 10% complete. That's the extent of our effort right now. That part of this is just sharing what we found and maybe discussing the path forward, right? But our effort right now is to 10%. And so what I'm trying to say is that we are on the left-hand side of the range, right? The contingencies that you're going to see on the estimates have to be in that range just for the purpose of being conservative. And you're also going to see some contingencies there for inflation, since the construction is going to happen in the future, so on and so forth. So I wanted to elaborate on that as well. And without further ado, let me turn it over to the rest of our team so we can dive into the facilities themselves.
Yeah, for this next part of it, myself and Tyler and Cameron are going to go through the facilities, facility by facility review, and talk through basic. I'll start with talking through what the facility does and why it's important, and then I'll turn it over to Cameron, who'll go through the evaluations that we did on each facility. So the first facility that we looked at is Headworks. Right now at the plant, there really isn't a Headworks to speak of. Headworks at a typical wastewater treatment plant serves two purposes. One is screenings. As you can imagine, when a toilet's flushed and that wastewater goes into the collection system and eventually gets to the plant, there can be things like flushable wipes or other debris that gets in that and can wreak havoc inside of a wastewater treatment plant if it's not removed at the front. What a headworks does is it removes those contaminants before it gets to the treatment processes, so the rest of your investments at the plant don't suffer from ragging and things like that that result in maintenance and headaches and costs over time. So your facility right now has some manual screening. One of the things that was identified with this project is how can we improve that? And that's what we'll talk about today. Not only the screening part of it, but the grit removal. Like Isaac said at the beginning, you're on an island here, so you have a lot of sand that gets into that collection system. That can be a real big problem. It can cause wear and tear on mechanical equipment, and it can start to fill up the bottom of your basin so that you lose treatment volume. So it's best to take that sand out, and that's one of the things that we looked at here with this works. So, as it over to
Right away. All right, so for first part, like Tyler's suggestion on the headworks, the lack of grit removal in the plant has allowed both fine and coarse materials to settle within the aeration basins. We noticed that when we first came out to site, and we had further discussions with Charles and the staff about issues that were being had over time throughout the entirety of this project. So as part of that, obviously, Garver recommended building an entire new facility to completely replace what's existing today. As part of that, multiple equipment technologies were evaluated during that second phase, which what Isaac was mentioning about those evaluations. So we'll look at these in two different slides, one for screening and one for grit removal. For screening equipment, Garver compared two different types of mechanical rake screens, so that we had something that was fluid and mechanically inclined. That would not be something that the operations team would have to work on all the time. They have to actually fish screenings out of. So we looked at center flow screens and multi-rake screens. They're both mechanical. Center flow screen being a version that is much smaller footprint overall, so that we're more concerned about that at this facility. Keep as much space compact as possible. So that type, which has multiple vendors that we can go to, has that application to it. For grit removal equipment, Garver compared three different types of technologies. We were given a couple of instances from previous pilot projects that were done at multiple sites. Andy Bowie had one with Lavelle separator type. We also looked at a mechanical force vortex grit removal equipment and stack tray equipment. Stack tray being what's used at Port Isabel today. So we looked at all three of those since operations has some experience with them, and that's something that we could provide to y'all as a opportunity for the grit removal. Going into Tech Memo 2, we had these all vetted out as we talked about, and we kind of came up with some conceptual designs at that point in time. As part of the workshop review with the engineering staff, we did review and choose each one of them. So the following improvements were determined, and we decided on providing a center flow mechanical screen for the screening process, and then a stacked tray grit removal system, again, because it's used at the Port Isabel plant already, so it's something that everybody's familiar with. And those two also have very synergy for footprint and reduction of space overall. So we optimize the spaces that we can put this on the existing site. And so based off of that, we went into our third tech memo, which again was mainly just conceptual layout using these two types of equipment that we decided on. So Garver created the layout for the new headworks. And this is actually due the eastern end of the facility, which we'll get to more in the VR, so you can actually see what it looks like across the whole facility. But this is directly to the east of the existing lower building. An elevated situation that would be elevated above any floodwaters, be able to be accessible from the typical driveways, also have an extra driveway that would be able for trash compactor garbage to dispose of any screenings and grit removal through the system. And then it'll be elevated in a way that we can tie it into existing facility structures, like the aeration basin, so that operations can walk from both and be able to see what's going on, be able to maintain it in a more accessible way. Yes, sir.
Where's all the stuff go once it's picked up? You know, like it's collected. You just were talking about, the easier access points to grab this up. Where does it go to? Is it dump?
I think so.
Landfill? Okay, that's what I want to know. Where all the wipies end up, right? The landfill?
Or-
The shaded where it's basically a dumpster.
Yeah.
All there, and then
Don't get behind that truck, right?
but it would be everything combined for both types of equipment into one. So keep that together.
It's been done for odd things.
I can imagine.
Bowling balls arriving.
Wow.
Two befores, a lot of odd things get done.
Driveway ones.
Yeah.
Thanks. So that's the Headwaters facility in a nutshell. So below that, as Isaac was mentioning, we did put together any probable cost, construction costs for the project. So this would just be construction costs to put the entire structure together. So that's a brand new structure from ground level. Some piping modifications that would be from lift stations to get it back into the plant and rerouting pipes, getting a new driveway in, new fence modifications. So again, we're looking at about $5 million total for that one structure.
So the next part of the plant is the return activated sludge system. So this is a critical part of the plant. All of your wastewater plants that you have in your system, they leverage biological processes to treat that wastewater so that once treatment's done, you can release that into the environment and it's safe and it meets TCEQ requirements. The return activated sludge system, what it does is it takes the sludge that settles, which is the biomass that's being used to consume the contaminants. It settles out in your clarifiers and it needs to be returned back to the front of the process so that that same biomass that you generated can continue to be used. Right now with the plant, you have an airlift system that recirculates that RAS back to the front of the system, and that's been an issue because it relies on the same air that's being supplied through the blowers to aerate the basins. And so the airlift pumps are, in a sense, stealing some of that air out that you could be applying to the aeration basins. So not only that, but some of the issues that staff had with keeping the airlifts operational. This was identified as a key element to replace, and Cameron's going to go through how we work.
So again, just going with Tyler, we do have a diagram of what the existing arrangement is here. So we're basically just pulling sludge from each of the 3 final clarifiers that are on site and transporting that back to the aeration basin. So as we've seen, the existing airlift pumps are outdated and unreliably transferring sludge back to the aeration basin today. Garber was recommending upgrading these to mechanical pumps so that we had something that we could actually power without use of air, that would be more reliable over time, something that we could actually maintain in an actual operational fashion. Due to the lack of the pumping efficiency, the additional stress is put on the blower system. So the blower system is where it needs to be just to actually aerate. We're starving in ways if we're using excess power to try to push the sludge up out of the clarifiers down into the aeration basin. So if they're not running at peak efficiency, nothing's running at peak efficiency. Multiple pump types were evaluated during the second phase of the project.
I just want to say, what also happens with the back of our headworks, you get rags, it's like pumps, that we open the pump. Got to top all the time. Y'all got y'all's solar now that y'all have on top of it all the time. So they're pulling the budget.
So as part of our comparison during the second tech memo and alternative evaluation, we looked at 3 different types of pumps. One being a submersible centrifugal pump, another being a flooded suction centrifugal pump, and self-priming pumps. So with the submersibles, while they're typically good for chewing stuff up if we need to, grinder or chopper type blade style, we would have to put a new wet well on site, which is not feasible, obviously, since we're on a floodplain. Flooded suction centrifugal, we could do the same type of installation, but we still have to raise a pad above the flood elevation just to keep the pumps out of the way, keep all the electrical components out of flooding concerns. The self-priming pumps, though, have a little bit more ability to pull from higher elevations than we want to, so we could actually lead into, that's what we actually chose as our preferred evaluation selected alternative, is that we could pull and actually locate these all on top of the aeration basin as a whole, while we can just retrofit in the areas that the existing airlift pumps are located. So again, it would be something that easily accessible for an operations team, or easily accessible to actually touch the pumps, work on the pumps. And
So that's basically, that's like a horizontal. It's kind of like we have at the golf course. Had.
it's on a horizontal.
Yep.
But self-priming, because it wouldn't find itself and just start it. So leading into what we did for conceptual design, and technical number 3 was proposed modifications here, which you can see is to put 3 pumps for clarifiers 1 and 2, so that we had 2 duty and 1 standby for any concerns or maintenance swap outs or anything. And then similarly for clarifier number 3 by itself, 1 duty, 1 standby. They would all be tied into common discharge headers, 2 common discharge headers, I should say. We tried to route those due to short circuiting that happens in the aeration basin today. Trying to bring them to the center where our raw screened grid removed effluent, everything can mix properly before it goes into each of the aeration basins. Right now we know that there's kind of a short circuiting happening with the aeration basin just because of its typical layout, so we're trying to resolve that. We're trying to send everything back to the center of the aeration basins. This would just be a couple of modifications around the top of the aeration basin. I'm saying some more operations type aluminum, stainless steel grading sections for operations platform, some new concrete pump pads on top, the whole structured man on concrete already, so we could rather easily gal into it, make some new pads as needed, and then a couple of piping modifications to make sure that we have the ability to get between the duties and the standby pumps. Question before we roll on. And again, just a cost estimate that we have for the self-priming pumps and escalation factors as we were talking about for just basic interest rates. We're assuming all of these projects or all of these could be separate small projects if needed based on budgetary. And that we would assume the dates would be out to 2025 for the actual bidding times. All right. Yeah.
The next part is the clarifiers. After you do your biological treatment, like I said before, you want to clarify that water before you release it into the environment. So you settle everything out. So that's what the clarifiers do. In this case, what we focused on was the largest clarifier, which is clarifier number 3, the one that you had caused the most problems with. And so, yeah. Take it away.
So again, during our visit, we one of the biggest issues that was brought up by operations staff as soon as we got here is this mechanism was not working at the time, so the clarifier was kind of defunct at the time. So we noticed that just because of being offline, nothing's moving around. So as you can see in the photo that we have here, the scum was not being able to be removed from the surface of the clarifier. So that needs degreased items that would be lifted up to the surface are not being able to be removed from the system. This is a suction header type, so it is actually pulling a pressure off the bottom up to the top to move the transfer of the sludge out of this clarifier back over to the aeration basin. Since the mechanism wasn't running, there's no different pressure that can really be had as much, so it was only pulling certain sections, it wasn't pulling from the whole basin. So again, due to mechanical issues, we saw issues with scum removal and sludge removal. Again, the sludge removal is in part due to the problems that are being addressed by the brass pump upgrades as well. So we looked at a couple of different options here, one being just a straight rehabilitation and 2 full replacements with a different type of mechanism if needed, and looked at both a scraper blade that's another clarifier 1 and 2 or a suction mechanism that would replace this with any kind of essentially. Based off of that second client review workshop, we decided that a rehabilitation would be the best approach for this one, since we know we're doing other things for the brass pumps and hopefully help out with this clarifier as a whole. And we know that clarifier 3 has since been put back online. We still need some upgrades and some repairs as needed. Most of the rehabilitation centers around that mechanism, repairing it, making sure that there's nothing else that needs to be taken care of, but also going in, making sure the fiberglass weirs that go around the launder that actually carry the clarified effluent out to the rest of the plant and out to the bay are level, so that there's no short circuiting in certain areas. Again, that could be a reason why scum populates in certain places and doesn't get out of the system. And then also replacing the scum sprayers. Right now, there's just a non-potable water line that's spraying from a hose directly into it. So we need to get some clean up there so we have a consistent system that's running throughout the plant and not using another hose connection that can be used for something else. Again, this is a rehabilitation cost for clarifier number 3 alone, which again is not too much equipment, it's mostly motor electrical type things and general maintenance type activities. So this would be a little bit easier one to kind of get through and whenever you're all ready. Okay. And I will turn over the LMWD Workshop to Brian.
Thank you.
All right, let's go to the most important facility, is the electrical part. We have all the upgrade without power, we can't do anything with it, so. Okay, on our last visit, we generally found the corrosion of the electrical equipment was identified, and then this was some, due to the modifications upgrade, the current amperage that's rated right now is 800 amp, so any upgrade will be not allowed because we don't have enough capacity for it, so that's what it is right now. The second thing that we found out was that the plant itself is in the floodplain. That's what the picture showing the square box. That's currently that's where it's at right now. So due to that, your reliability is going to be very low. If there's a flood, the system could be arc, and it could just flood into the water. And we found out that MCC1 is not used right now. It's abandoned, so it's just in place in the low building. Of course, we spoke with the staff, and they requested for Garver to explore the installation of new UV disinfection system, and because of that, the current electrical system is not capable for that. So some of the improvement we recommend is to relocate the transformer to a bigger transformer to for the future load. And as you can see, the picture showing that right now the transformer is actually on level, and we need to be raise the height above the 100-foot plane. So that's what we identify. Other electrical improvement we recommend is to demolish MCC1 to make space for other things, and then replace MCC2 from 800 to 1200 or 1600, depending on the capacity we're looking for. So that way we can have new MC for reliability at the same time, have enough capacity for the improvement. And of course, all new electrical gear will need to be elevated 18 inches above the 100-foot plane for reliability. So identify the cost for that. Right now, it's looking around about 1.9 cost for construction cost. I'm sorry. So for the transformer, basically transformer taking a high voltage from the utility, step it down to 480, the voltage that we're using, and the kVA rated is based on the capacity of how much we need. So, example, 500 kVA transformer will roughly give you about 600, 650 amp. So the picture I showed earlier, that's what it is. So if we need anything larger than that, we have to have upside that transformer. And the MCC stands for Motor Control Center. Basically, what's that doing? Taking the main power and then distribute it to all the equipment that you use. And of course, MCC, you can have the starter in it, and any control can be put in the MCC.
I'm a civil engineer, so those MCCs, transient electrical panel, big box on the wall. All right, so the effluent discharge system. So basically, as water is treated, we collect it, we run it through an outfall structure where the water then flows over the weir. It's highly treated effluent, flows over the weir so we can measure how much flow it is, and then it's discharged into the bay. As it leaves the outfall structure, it flows through a 30-inch diameter pipe. It gets outside the fence, then it goes into an older manhole. That 30-inch then gets narrowed down to a 15-inch pipe, which was it the original pipe where the 30 inches was an upgrade, but that transition from the 30-inch to the 15-inch is a constriction that's causing backups on the site. So I'm going to keep moving, and I got a 50-50 shot on which one moves forward, down. Okay, so the constriction in the inflow discharge piping is creating a plant overflows during wet weather events. The 15-inch can handle the design flows. However, during a wet weather storm event, that it just does not have the capacity, and it's creating overflows within the plant site. So the effluent piping exists. Let's see. So back in 1992, there was a project where I believe clarifier number 3 was added, and there's several other improvements that were done. At that time, best we could tell looking back, that 30-inch pipe was constructed and tied into that manhole. The intent was to replace or to install a 21-inch diameter pipe to run parallel to that existing 15-inch all the way out to the bay For whatever reason, that pipe was never installed, and just that 30-inch was tied into the 15-inch, creating that constriction that we have today. Photos here kind of shows you what that manhole looks like, where the 30-inch comes in, it makes a hard dog leg right, and flows out into that 15-inch outfall. There's an abandoned 15-inch pipe. We originally thought it was a storm pipe that was feeding in to help with some of the stormwater drainage. But the more we looked into it, the more we thought that may be the original effluent piping coming out of the plant before that 1992 upgrade. But regardless, it's abandoned. It's not really providing any value right now. So installing a new parallel effluent pipe will provide relief during wet weather events. So what we are proposing is to either install a new 30-inch pipe to replace that existing 15-inch pipe from that current manhole all the way out to the bay. However, we may look into a little more investigation on that existing 15-inch pipe. There may be still some life in it. And in a 15-inch paralleled with a 24-inch, we believe would also take care of that capacity. There's probably not a big price difference between the 30-inch and the 24-inch. So in my opinion, that 15-inch pipe's at least 40 years old. So a 30-inch pipe probably makes the most sense. However, as we cross the fence, as we cross that little road, we get into the U.S. Coast Guard property. Crossing that property, crossing federal lands is a little bit of a challenge. It's going to take ultimately take a modification to the real estate agreement. I'm not sure the steps are going to be taken, and I've done a lot of these projects in my years. Best thing we can do is really start communication with the Coast Guard immediately, find out what they need, and just follow their rules, because they won't accept it any other way. This may have been what stopped the project originally way back when. It was just the cooperation with the Coast Guard, or it may have been just due to costs. I really don't know. It's kind of speculation at this point. But really the point is starting that communication with the Coast Guard as soon as possible in order to find out what their requirements are going to be, if they require an environmental assessment, whatever it may be, just get that ball rolling, because it could easily turn into that critical path in the schedule. So really, I got the costs are combined with the stormwater piece to it as well. So let's kind of jump in on that. So the entire site, as Brian said, is located within the regulatory floodplain. We're well within it. In fact, I believe we're about 6 feet deep in some parts across the site on the 100-year floodplain. However, but we can provide drainage improvements to provide immediate relief on more of a routine type storm event. The site drains to the north. And then from the north, it falls into a drainage channel, and then it's conveyed to the west. That drainage channel is heavily overgrown. It's actually been cut down a little bit here recently as the surveyors got out there so we can survey the flow line of that channel. But ultimately, as it flows to the west, it runs into basically it's a dead end. There's a loading dock that has been built, a loading ramp has been built out over the next to that little road area. I believe it's the county. I could be mistaken on who that is. But basically, when they built that road, they didn't give a good, clean way for that water to drain across, and that's causing all that water to back up. So even if we clean out that channel, if we don't put in some sort of culvert, some sort of crossing for that storm water to get out, you're still going to have this trouble you have today. But ultimately, that water needs to flow to the west into the bay the way it did years ago. Looking at some of the old photos back of the room here, it shows this plant before that loading ramp was built, and you can see just kind of looking at where the vegetation was, how that water used to flow out to the west of the bay. Right? Yes, sorry about that. I know north-south really well, east-west on the outline, getting it up. But also there's some of the storm drains that are within the plant site. They convey back to the influent lift station, which ultimately takes that storm water that runs it through the plant. That's really kind of wasteful to treat that storm water, which should be running off. So that's some of the other items that we've identified. So with some simple drainage improvements, we can reduce flooding during routine storm events. First recommendation is to clear and reshape that channel on the northern side. However, if we don't install a culvert under that loading ramp there to the northwest, I really won't go anywhere. So to fix most of the drainage problems, clearing and reshaping that drainage ditch and putting in a culvert across that property to get that water to the west. And then to The other recommendation is on these area drains, we can install a gate valve that, so when it does start to rain, we go out and the staff can go out and close those valves. So where the storm water will run off of the site rather than flowing back into the plant. It would really cut down on some of the peak wet weather flows that are coming through the plant. So these are basically the modifications we're suggesting to alleviate this drainage problems. Rolling up all of the costs for both the effluent piping as well as stormwater drainage, really looking at a total project cost of about $1.8 million. That is it on the civil side.
So we've got two more facilities to look at. The next one is the solids dewatering. Basically, with a wastewater treatment plant, as you're treating the wastewater, as you've got the biology that's growing to consume the contaminants that come in, you've got a lot of cell mass, the biology that's being used to consume all this contaminant. It needs to go somewhere at the end of the day as you're clarifying it. So how most wastewater treatment plants deal with that is that they pull it out of the clarifiers, they hold it in a tank like we have here in the sludge holding basins, and you dewater it because it's costly to dispose of these biosolids unless you dewater them, because otherwise you're trucking water off site. So what we looked at here was your existing dewatering facility and maybe how we can modify or upgrade that to make it better.
And one of the big things we noticed, and you kind of see it in the right-hand side of this picture, is the front-end loader that's used for all of this. So operations is actually having to do that on a consistent basis rather than it being automatic conveying from one end to the other. So again, just going through that evaluation process, we identified the existing belt filter press building as a pinch point in the site. It's very tight on that side. There's other facility uses over there, including the next one we're going to for disinfection, which is the chlorine cylinders on the site. So there's a lot of traffic that goes through the northeast corner of the entire plant. Existing solids removal from the belt filter press has to go through that front end loader to actually remove it from the northeast corner to the northwest corner of the site, just to get out of the plant and go into roll-off bin. With that, we also had some staff input about different types of technology that they want us to look into for dewater. As part of that, we reviewed those and we recommended the inclusion of automatic conveyance for that dry system, just to get rid of that operations need, make the plant more efficient overall. So Garver reviewed the following equipment types based on the previous Laguna Madre staff experience, is primarily belt filter press, which is today on site in the dewatering building, and also screw press. And there's two different types of screw presses to look at, but there is one called a volume press, which is the very bottom picture, squeezes and compresses at the same time, so you get a little bit more efficiency out of it. But that is being used today as a mobile press that y'all can use to multiple sites. So it's on a trailer, goes back and forth between all the plants today. So for that, after discussing this with the staff, the engineering staff, we agreed that the recommended equipment selection would be a volume screw press, since it is something that y'all just purchased, that y'all are liking for use in the mobility of it, as well as having a new static one that would be more efficient overall. So we would provide a new volume screw press. This would also come with a new building, new facility. So we would relocate it to the northwest corner where there's existing sludge drying beds that are being used as to their peak. So we'd have some extra footprint on that side. So we would build a new operations platform and have an automatic screw conveyor where we had to drop into the roll-off bins. We'd also install some new pumps to transfer solids from the aerobic digesters to the new dewatering equipment. So it would be great thing. And so again, after we made that decision, we went into our third tag memo to come up with our conceptual layout. So based on those staff selections, Garver created a layout. Again, this is the northwest corner of the entire site where we have a new platform that we built. Volume screw press is an entire system. It's not just the screw press itself. So there's a flocculation tank that kind of gets everything mixed up so we can continue running, actually move the solids and dewater them properly without stuff settling before it even gets to the presses. We have this volume screw presses. There's a polymer system that keeps everything kind of coagulated as well. Then we would have all of that discharged into a secondary screw conveyor that would drop directly to the roll-off bins, 20 cubic yard roll-offs that are already on the site that can just be centered underneath the chutes and just basically drop into it from there. You can see in the kind of the bottom left-hand corner there of the platform, there's a bunch of little squares and rectangles, but those are equipment cabinets, so we're raising all those up above the floodplain elevation as well. That includes this facility as well as the next one we talk about for disinfection, which is the UV facility. And again, there's the cost for that solids dewatering by itself, about $3.2 million. Based on one of our vendors for the volume press, it all comes basically as a package. All the equipment, all the operations platform they would provide, and it would just be something we could plug and play in place once we developed out some of the sludge dewatering beds and be able to use that location.
The last facility is UV. So the last stage of any wastewater plant is to disinfect that water before it's released to the environment. So there's, as you might imagine, there's pathogens in the waters, there's disease-causing organisms that we need to inactivate to disinfect before we release it to the environment. The permit requires that as well. So right now, the method of disinfection that you have is chlorine disinfection. So we looked at that and how we could potentially modify that or how well it's operating now. But we also compared that to UV disinfection, which is a way of using focused ultraviolet light to gargle up the DNA and those pathogens and microorganisms so they can't reproduce, and you're effectively getting disinfection that way. So that's what
Tyler mentioned, when we first came to site, that was a big talking point right as we got our contract, was to look at chlorine as part of the area had gone exponentially high in cost. There's an increase in the chlorine gas cost for rentals, for transportation back and forth in and out of the site because they have to constantly be filled based on the capacity of the plant. That was obviously causing the staff to have to revamp budget departments on the fly on a month-to-month basis to make sure that those costs were covered, because this is truly one of the most key points of the new facility. UV disinfection systems will provide a cleaner disinfection process while reducing the need for the chemicals on site. So to get rid of the hazard mitigation plans that are needed for the site, operation safety training, all of that type of issue, especially with the area around, especially having the LV park and the theater and everything else around, that would kind of help out, save some time and efforts, and not have to rely on that plan at all times. UV systems, though, would greatly increase your overall electrical load, which Brian already talked about as part of the electrical increase. So that is kind of focused in the UV systems. So for the UV equipment, Garver compared two different technologies. There's inline type, which is directly in a pipeline, and in-channel based, which is what we're trying to go to next. We looked at both of those against the existing chlorine gas system, see how they would be affected. So chlorine gas, again, systems are in service, capital costs required to do increase participant contact time as based on the TCQ regulations would be the only main concern there. So we have to upsize one of the structures. Disadvantages, still high monthly costs, hazard mitigation plans, expected operations and maintenance costs, just over time. UV, open UV, we'd be able to retrofit into an existing channel basis. So we would be able to retrofit clarifier number 3's basins to rework the system and put a UV system in. There'll be some minor modifications for piping to reroute, make sure that we get everything upstream of the UV banks, but otherwise work within the existing footprint. And then the other one would be an inline UV, which, as you can see in the top right-hand corner, is directly flanged up into our pipelines. So then again, we would have to raise that above the flood elevation, make sure it's all out of the way, because there are lots of lights, as Tyler's referencing to. These are standard bulb, UV bulbs that are used every day that can be easily replaced, but we don't want them sitting in the water if there's a flooding event. Again, both of those do come with a higher energy consumption, which would have to be taken care of, electrical upgrades, and just overall monthly cost of the electricity. So to install the UV systems at the disinfection facility, the following improvements would need to be made. This is going with the in-channel design rather than the inline design. UV bank system could be installed within the existing disinfection chambers at clarifier number 3. And then there would be some piping and structural modifications. Again, the piping would just be rerouting what comes from clarifiers 1 and 2 over here, so it's all upstream of the UV systems. Other than that, there's a existing wall that partitions a portion of the clarifier 3 system as it's running around. It would just demo out so that would have the sufficient space to put in the UV system. And there's two types of in-channel. There's an inclined and a vertical. I won't go into too many details, but they're the same basic approach for both of them, just different and have different applications. But again, budgetary constraints come in hand. You have a system that will work as is. Secondary recommendation would just be to upgrade the existing class chlorine gas system, which is really updating the chlorine contact basin A, which is directly north of clarifier 1 and 2, to give additional contact time so that the TCQ regulations are hit before it is then outfall to the infrastructure. Everything else from capacity, cylinder-wise, tonnage-wise, capacity is all fine as is. And so we put 2 different cost tables in there. One that would be directly for the UV, which is the 4.0, mainly because of high front-end cost of buying the equipment, installing it, doing some minor modifications around the system, whereas you have a low capital cost for the chlorine because it's really just structural modifications at that point in time. You do still have to have the hazard mitigation plan, so there's some other costs associated with that that are outside of this a little bit, but they're just day-to-day basis, operational type stuff.
That we're already doing some of
That
it.
you are doing,
Yeah.
correct. But you have to keep updating it and updating it as needed.
What's your annual chlorine cost for department?
We just did it this year.
Thank you, guys. So that's basically the overarching explanation of the project. Hopefully that explained what we did and how we did it, the conclusions, what we went through, the deliberations. There was a lot of discussion. There was a lot of alternatives evaluated. It was a very productive effort. And right here, this is a summary of the selected alternative, the selected solutions for these facilities. And we've, like I said at the start, if we were looking at it from 0% engineering to 100% design engineering, we're around a 10% point. And that's where this current scope of work ends. What would be next is discussing a path forward with the staff and see how we move forward, because as you saw, I mean, it's an investment, right? There's a lot of expenses here. All of these facilities, nothing at this scale is cheap. So it's deciding what is urgent, prioritizing basically what's urgent. Is it one project? Is it piecemealing some of these components? And that's why also we ranked it, right? The headworks, it may be the lowest hanging fruit, and that'll solve some of the problems, and then it can be separated, etc. So in the engineering report that we've delivered, that's basically the final deliverable of the project. It goes way more in depth into each of these aspects. It goes way more in depth into all of the evaluations, the process. It describes everything that we did in detail. All of the cost estimation is there, so you can peruse at your convenience. And we're right on schedule. I mean, I'd be glad to discuss any questions that you'll have right now, or we can dive into the fun stuff and go.
Well, I have a quick question.
Yes, sir.
Is there any thought to retaining that water after it's treated? And then, we're always looking for water, and retaining that water and using it for irrigation
Yeah.
I've been at golf courses where we irrigated the entire golf course with reclaimed water. I just don't know if that's just out of whack when we're thinking about numbers, but if we could pilot that into a tank and be able to use that for the city of Padre for irrigation or anything. I didn't know if there was any thought given to that.
Yeah, and maybe Charles can elaborate a little bit on that.
Yeah, we actually had a reuse permit in 1997, and so all the Causeway medians used to be watered with effluent from Isa Blanco. And so that permit expired, and to really get it under the current Chapter 210 rules, we have to build a filter system at the fill in and go through a separate permitting process. So
But the pipe's all there in ground? We could tap back into it?
Well, they built that bus transportation
Oh.
center. That pretty much is where it used to build the irrigation system.
I
So there'd
gotcha.
be some piping modifications, and I mean, they used to pump there off of chlorine contact basin A. And so I think it's just a matter of if that gets restored, doing that reuse project.
It seems like every day we're looking at a graph where we have less and less water every time we have a meeting. And
Yeah.
so that idea that, we can do something else with it.
So, I mean,
And then,
I believe one of the issues that we're having off that irrigation system there is that the salt content is too high, and that needs to be looked at. Salt removal has to be in process before they utilize it.
Yeah. Yeah, we had the same problem.
They're getting brown colored grass instead of green.
Bypass Palom, they'll be fine.
yeah. And then, well, you know, plus you have to post the signs, do not drink the water as you're coming off the causeway.
Yeah, you gotta have purple pipes. I know there's a whole thing about that, yeah.
People didn't like those signs.
I mean, the answer is that yes. Is it realistic? Is it feasible? Yes. It's of course an investment, an expense. The district has actually been very proactive in that. They've done some legwork before. But I mean, that's part of the future, right? Desalination and reuse.
Well, I mean,
That's
doesn't that help us to avoid the Coast Guard problem?
the discharge.
Yeah,
You could save all of that water somewhere, storage may become.
well, yeah, storage might be the issue. Okay, I understand.
Carlos, doesn't been done to that plant since '92. There's been no upgrade since '92.
They've been, upgrading like minor stuff, clarifiers, for instance, they worked on one of them and then the aeration, the electricals, very minor, but you can, go ahead and.
Like a blow room would have some
Mark is a manager there.
modifications, small ones, like Carlos said, blow room and, clarifiers. So real small, nothing major.
No full-fledged.
When something breaks, they go in and replace whatever is needed. So
Right.
nothing major like this here.
Yeah, even our small scale kind of interim electrical upgrade wasn't funded, so, you know, we're taking it, this is just trying to get it all done on a full scale for everything that's needed.
Just did the roof, blow room.
Right.
Yeah. So I mean, most of the issues that we see here are aging problems. It's just due to the age of the facility, and a lot of this, it just you can do all the O&M you want and keep up with everything, but still facilities deteriorate, especially in out here so close to the ocean. Things just deteriorate. So it is a lot of some of this. It's just basically time.
Plus the technology.
Yeah, of course, yeah.
Just like the headworks, you don't have a good headwork.
Yeah.
And that's a necessity because the sand accumulates in there. And, they
Right.
end up going back in there and clearing it up. And then the following year, doing the same thing again and again, you know, it's always accumulating.
Well, I see you have it ranked as far as, you know, what's the urgent, so what kind of timetable would you look at?
Well, first of all, you probably have to look at the funding part, where the funding is gonna come out of and then bring it to the board and you guys approve whatever, is available. But, just, funding is.
Yeah, I mean, the funding is what's gonna drive the time, and I mean, that's years away still, so that's kind of where we're at with it, just to get our funding in a position to be able to handle a project like this.
But we're looking at all kinds of, and also have done that, grants and, you know, the state. So, I know that, you've been looking at that too, but that's all we need to move forward with.
Yeah, in the past, we funded these types of improvements with revenue bonds, right? So to sell those revenue bonds, you have to pledge revenue. So how much revenue, you know, that revenue comes from rates. So, you know, we're you know, if we're looking at a big project like this, we're talking about well over $1 million of revenue that we would need to generate. So again, that becomes a policy issue where you want to raise rates and you know, to get the revenue that you need to finance a project like this big. You know, would it be possible in phases? You know, that's something that you could think about, is, you know, maybe breaking the project up into multiple phases would be something. It looks like it's possible the way that they've broken it up among the facilities.
When are we done with that tax bond?
The 2020?
Yeah.
Well, I guess the 2025 would be the contract that's currently under construction. We're looking at finishing around September 2025, somewhere in there.
We have used up all the funds.
Well, I'm gonna discuss that at the November 8th meeting to see where we're at with the balance. So I still we got to crunch the numbers to give you the exact status of.
But none of those numbers are going into the decel, right?
Well, that's where I think I'll talk about it in the 8th. Like, as far as for us to continue work prior to the next round of funding from decel, I'm thinking of using those surplus funds from the Series 2022 tax fund to do the next work order.
I mean, it makes sense to me when it's easy to sell to the voters, hey, we did a tax bond in 2020, we got the money, here's what we improved, great, it's looking good. We are gonna need to do another tax bond for our next set of upgrades,
Right, yeah,
starting in 2025 or something like that.
right, because we are limited to water system improvements for the election. In 2017, we did an election pursuing wastewater and health. So if we want to try to take another shot at a wastewater tax bond.
I wasn't on the board then.
Not our problem.
So 2025, I mean, if you think we're gonna be done our tax bond stuff, great.
Well,
I'd rather do a tax bonds than rates.
yeah, and a bond election is our fastest path to getting funded, even if we wait till the November or May round for an election.
I mean, I don't know how you guys feel, but it's like, hey, we always have to do upgrades.
You can't just keep asking for
You know,
money.
it's kind of similar to like HOA stuff. Do you increase your dues, you just do an assessment and knock it out. That's how I look at these.
And I mean,
You know,
to
rates
spread-
is what you want to be paying for every day, and then upgrade time, or got to take care of our facilities time. We're gonna hit you up with a tax bond. It's in everybody's best interest. This is why we got to do it. It's easy to explain it itself. And I would package as much into that as possible.
Right. And I think right here, we already got our bond engineer's report if we want to pursue the election. I mean, that makes a lot of sense.
Yeah, that's how I would do it. I mean, I don't mean, I'm not talking about next year. I'm not talking about
Yeah,
Biden
May and
time,
November.
but the Biden-Trump election. I'm talking about the next one.
Okay, well, I mean, if we're thinking November, for us to get on the election, we'd have to call the election in February for that. Or was it February for May? Or, yeah, we have to work on those timelines with on the election.
We would want to talk to people who know better about whether it's better to try and do that during a presidential election or an off year, right? I don't know which one is better for us to pass upon, so we want to talk to those people.
Kind of both work for us.
Yeah.
How much did this one pass by?
Just 70%, 71%.
That one was good. That's because we think we sold it well, right?
Yeah.
Went around, we explained to people, and I really think, you think that's the reason why that passed versus the one before didn't pass?
Yes, but this one, we had the ad hoc committee that didn't exist
Yeah.
prior to that.
Yeah. Are you gonna say something?
Yeah, with a water project, you have more, people see it as it helps everybody. With the wastewater projects, one of the criticisms is that people think that it's more of a regional project. So like this thing, it's possible that people might see it as a problem for the island. Yes.
Great,
Yes.
why don't we add something in Laguna Vista then, to the project, so that it's wastewater facilities upgrade? That's what I would do.
That works.
Mhm, mhm. That could
Right?
be-
Just show that it's balanced, right?
Mhm, mhm.
And again, all four systems that we have, you need some kind of attention.
Yeah. And I mean, if we want to take it to the step.
I mean, all these guys, I just were like, oh, awesome idea, yeah, let's do more in other plants.
Well, also, like, if we want to call it as a reclaimed water package, so we.
That's
look
our
at
job.
true
That's right,
reuse.
that is.
There you go. Yeah, just rename it, clean water package.
Right.
Or, I mean, we have to also give consideration to what we're gonna do with desal as well, because we can't be trying to do two. We got packaged everything together into one thing, if that's how we gotta do it. The less times you go to hit people up, the better. Better hit them up one time big than two times medium. But they'll say no to both, or yes to one and no to the other, that's not the way we do it, so. At least that's my thought.
First one wins, second one
That's
loses.
good information.
Okay, great, just as we think going forward, and as you guys are thinking, in my mind, if we're gonna be done that tax bond, and it'll roll off our books, it's time to do probably another upgrade tax bond.
Yeah, well, I mean, because right now, what's our tax rate at? 7 cents or?
Yeah, it's about 7.6.
Yeah, I mean, I really think hooking it up, like Mr. Johnny just mentioned, to desal it's a no-brainer. They have to kind of go hand in hand, you gotta treat the water you use, so put those in on one bond. It makes a lot of sense. We gotta start, I mean, this is a workshop, so I guess we can talk about whatever we want. So we gotta start that education process, and we might wanna think about how we go around doing something like that. I think, like we said, getting a committee together, is the best way to start educating people. Just running an HOA, I can tell you 95% of people understand and are great, and 5% just hate everything you do because you're alive. So we have to make sure we get out there, and we can't do anything about the 5%, but we gotta make sure the other 95% listen to reason and listen to the advantages rather than people who just are angry. Make sense? Okay,
Yes.
great.
Anything we can do on our part with that, glad to help. Someone said that instead of wastewater, it was clean water. That was a perfect point.
Right, because I mean, we had the lift station needs that could be part of the project, and, there's the flush building.
First thing they say those.
Any more questions?
Stop building homes, stop having the golf course, turn it back into a desert.
Anyways, proceed, where are we at?
Well, if there's no more questions, and we still have time for questions as they pop along, but let's jump into the VR model and do a tour of the facility in the rendering. Super pretty cool.
Great. What do we do here?
We go over there.
Over there. And everyone that is not wearing a headset will be able to view it here anyway.
Okay.
Oh, like that.
No, casi ni doble. Mhm.
Kilowatt wise.
Okay. Por,
Well, right now our monthly bills might be 12,000 somewhere in there, so I don't know how much of an increase we're talking about.
porque
on the load.
llegaría el lunes o si lo pido hoy.
That's dollars. Like is it, yeah, our monthly bill, it is Blanca for the plant, but
Okay.
it's about 12,000.
So what's the,
I guess I don't know what the load, how much.
yeah, we're gonna put it.
Sure.
Yes.
This one? I got that. Yes, I mentioned it too.
Yeah, that includes the transmission line charges. I think our contract's somewhere in the 34 and then they add line charges. Yeah.
Oh.
Yeah, we still have a pretty good contract. Yeah.
So roughly cost you about 1,000.
On a monthly basis.
And that's running.
Right.
Yes.
Yeah.
Part of how many turn takes you go through in a month.
You don't want to walk it first.
At least. And then
So how many? How much is that right?
So if he's using tanks, it's wasting maybe about $40 plus the sulfur dioxide, it's just $200 less, so maybe another two sulfur dioxide or just one? One, so that's about $600.
This is what the finished facility would look like, is that right?
Yeah.
And how often would you be changing those?
Sometimes like 5.
Just weather accurate. 5 years?
Yeah, wow, not yet. We can actually set this
I just, your initial investment is the one that's hard to get through.
Yeah. The piping would get moved. Yeah, instead of the piping come up from the bottom, it's gonna come up in that low side under thing. Yeah.
I think they just kind of took it in their hands, we gotta do this and turn on top of it.
Yeah, they've definitely done some fill that's caused the impacts on that. Yeah, when they built their impel, they built the impel on their drain.
That's easy.
Yeah. But when they put that lot in the public service, the public works lot that's there, and they had to put maybe 2-3 feet of fill in that drains. You know? Oh, the difference in cost?
Yeah.
Okay.
So roughly, because you not using all 100 it's using less than that.
Okay, yeah.
So based on 9 cents, it's actually
Yeah, so you're gonna save a ton on just the
Yeah.
Weird. Yeah, and then I think with AT was that workers power.
I don't know exactly the advertised gaming that it's up.
Yeah.
So that could be versus but that's
These guys are gonna get back here.
that is UV.
I'm staying on when I work out. Yeah, that's dinner. Well, I'm out of College Station, but I'm gonna work, I'm gonna stay at, I'm gonna stay one more night.
Okay. Okay, yeah. Get it through like the skate and everything. Yeah, that's nice.
All the MCC. That's more
Yeah, we already got our electrical building in place. We just need the equipment. So yeah, that's just.
Yeah, I remember I was at the city when you guys came to present the 2017 bond.
Yeah.
And people stayed here, and to be honest with you, they really and you guys, yeah, exactly. People really didn't care. Yes, I mean that's where I think we could have made it. People really didn't. Your employees have to shovel stuff. It sucks, you know. Exactly. That was the attitude. Like nobody really cared. And so I think that's the challenge with the so for the people in Ireland, it's why should they pay, right? Is the problem. For the people here, it's like it's not our problem. They need to pay it for it over there, right? So that's where it's like, why are we gonna pay for improvements on some project?
Yeah. I mean, that's why you gotta show that it's a true wastewater job that helps everybody.
Yeah, so is there improvements in Portersville and Ragusa that could be thrown in as well to make it more of a comprehensive tax?
Yeah, what I would do is I would put the lift stations on there. That lift station that's like a water tower, and that and so just the back, because you know when it's subdivision, that's what I wanted to show you, the water tower, since it breaks, basically that's going to trigger upgrades to and send it to Portisville. So good for one, bad for the other. So what would you like to receive?
Here's my answer.
That would be the win. But then we could reuse it and send it back to our reservoir. How many people would be like, unless you and Becky to be a part of it.
Oh no!
Odor control must be in there.
You better have a violin or whatever the hell they need. That better be part of it.
I think my wife's on reason.
You gotta know your own.
Exactly. Exactly. No, we haven't seen it. Let's do it.
I studied the map so much that I know it's absolutely perfect.
I just think you get the toward the wastewater plant, you never cross the road. It's safer. Right? Well, let's make it 40.
Cuando estuvimos haciendo los videos, conocí a ti, no conocí alguna vez cuando andábamos limpiando el canal, ¿te acuerdas? Conocí a Andy en los videos. Isla Blanca, pues sigue varias veces con el techo, con portes y todo eso. Y pues esta también en los videos, y luego una vez que entró agua, no me acuerdo qué pasó en el cuartillo ese donde tienes todas las computadoras. Pues sí, yo creo que la que más es la blanca, la una vista. Cuando vamos ahí con la maquinilla esa. Como la maquinilla ahí, es que se desahogaba como un canal y se ve como una orilla, no sé. Se ven las huellas de las marranas.
Yeah, we started talking about GPS family. We didn't talk about the control panel that's kind of playing around the person side.
UV should be in the channel.
Lo pude ver en la mañana y iba a llegar a HV y New Guys a las 12:15, 10 a las 8.
I've been doing this a long time, but they're my experts. Yeah, the disc, there's an election channel in the disc to, and they all run on the center pipe, so the flow would go to the center pipe. We would have another wall somewhere in here. The only way flow would get that, through that wall again. And then it goes, and it builds up. Space, it flows out people. To the UV.
I did already.
Any of the remaining sediments.
I'm gonna try. ¿Qué va a hacer o no? Kind of neat what you decided. Sit down, you won't go.
I didn't realize we hadn't done that much since I especially I ran most of the time. Got the plant stuff.
birds, any voice, one time over there.
And you were saying, so I ran out of a few walls out of that. But you know, I think it's
You have to just adjourn the meeting.
Really? Are you gonna adjourn the meeting?
What do you think will be our?
More meeting divided by 200,000?
Like see where, you'd have to practice a little bit with, you know, young kids nowadays, they do that all the time. They got-
Oh, I'm gonna check it out because I myself haven't used it yet.
Really?
Yeah.
Yeah, so- Well, I think he's right that we probably gotta sell something like this with resale. People know we're running out of water. It's down, way down. I've been on board for these 3 years. Everybody knows we need it, you know, we gotta have water. It'd be an easy sell, I think, anytime. Kind of like the Biden thing.
All right, we'll adjourn this here. Unless you have any more questions.
No, I don't. Thank you so much.
Okay, thanks, man. All right, I just want to thank, these guys can keep playing. I want to thank you guys for coming down, sharing this with us. You know, we're pretty proactive board in terms of upgrades and seeing things continue to improve here. It was just a matter of money. So when we figure out how to get it, we'll keep moving forward with these projects. And I just saw our wastewater plant manager leave, but a big thanks to anybody who deals with that because it's a tough job.
Yeah.
A lot of respect for the men and the women who put themselves out there and go on these sites because I couldn't do it. I'm looking at a dirty old mouth. Think of that. So thank you to you guys. Thanks to everyone else. Any questions, any further comments before we adjourn? Great. Motion to adjourn?
Second.
Okay, good.